Okay. So, first thing we need to do, we're talking about proportions in similar figures. First thing we need to do here is figure out what similar figures are. Okay. So when we talk about similar figures, we are talking about the exact same shape, not necessarily size. So similar figures have exact same shape, but can vary in size. So if you think of, if you've ever done models, or a model of things, a model is a 3D picture of something bigger. So some people do models of cars, or you can buy a Matchbox car that is a model of a car that's in the world. Matchbox cars, I don't know if they are similar exactly, but I think they are pretty similar. So what it means is they have the exact same shape. One is just a lot smaller than the other. Okay, so that's kind of what similar figures are. We also have shapes of things, which we can draw. Give that to Brownson, please, the printed out part. There you go. Okay. So, in similar figures, all the dimensions in the two figures have the same ratio. Okay? They have the same ratio. Okay? So, one example that we can look at that's pretty, I'm going to talk about 2 or 3 different examples, but one example, a lot of times we do this in 2 dimensions. Okay? So we're looking at, which I don't think are very exciting, but if you look at a map, okay, a map is actually representing where the streets are, and it's proportional to what the streets are in real life, okay? That means if I have something like, here's my map, here's my neighborhood, my street's going across this way, my avenue's going this way, so we're gonna have some here like this. So basically you have this, now one road goes up like this road goes like this dead ends, this one just keeps going straight, this one dead ends right here, this one, it dead ends back there, this one goes up to that. I'm just showing you some weird things on our map, okay? This one has another little road that goes like this, and then it goes out like that. This one just dead ends right there, okay? So you can kind of see that might be a neighborhood, okay? Those are the streets in your neighborhood. But when you come out to, there's this little area that's all nice and pretty, and then the roads go kind of weird. They dead end, they come out and they go on different plays, etc. That's what a map really is. It shows you that. If you're looking at maps, they usually have a scale. What the scale is actually the ratio or the rate, because it can be either. So it's either going to be the ratio or the rate of the size compared to real life. Okay. A lot of maps, it's 1 inch is the same as 4 miles. That's one way they can do it. Okay. Some maps do 1 inch is the same as a half a mile. Okay, so usually they give it in inches to miles because an inch is a lot shorter. If you were in Europe, it wouldn't be in inches. They may say 2 centimeters is the same as 1 kilometer, because a kilometer is what they measured theirs in, not miles. Okay, so we can have different types of scales. It depends on how big you're magnifying. Think if you go to a copier. You guys ever went and used a copier? Have you enlarged it? Have you enlarged something? No, okay, if you enlarge it or you make it smaller, you are actually making a scale change to that. It does it all for you, okay? If you send a picture in to get developed, which nobody hardly does anymore, but if you want an enlargement, let's say you want a 5 by 7 of your picture, then it takes the picture in your little camera, it's small, and it enlarges it to 5 inches by 7 inches. So that's what it's doing. And so that's, this stuff is used all the time, okay? But to read a map, we actually have to know, if you want to know how many miles it is, now you guys got Google Maps and all those apps that give you all this. But back in the day, this is how you would figure out what it is, okay? And so you can look at it and you can say, okay, I'm going to measure this, and it measures out to be 2 inches. Well, if this measures to 2 inches right there on the map, how many miles is that actually? It's 8, right? Because if I have 1 mile to 4, 1 inch to 4, then 2 inches would be the same as 8. You can also do this, 8 divided by 1 is 8, so that would be 8 miles. So you can figure from this the size or the length in miles, and so it's just a scale drawing. It's made smaller so we can look at it. Because we can't look on top. We do not have the advantage of going up above and looking down at a neighborhood and telling out how many miles they are. We can maybe go up in an airplane, but you're usually moving in an airplane. You're not staying stationary and you can't measure it.
With a drone you can.
Pardon?
With a drone you can.
You might be able to with a drone. Okay, that's one example. Maps. It's kind of an old-fashioned example because we don't use it as often anymore because we have all sorts of other things. Can somebody think of another place or another time we make a smaller scale item on 2 dimensions? Does anybody think of one? Has anybody ever built something?
I was saying like when you 3D print something, like you could take a shoe like 12 centimeters down.
We could do that, but that is actually going to be the next thing that we're going to talk about. That's not 2-dimensional. 2-dimensional is like on paper. Yes.
When you said built something, could you do like, let's say you had a board that you needed a different size and you cut it down, would that count?
That is a ratio. If you wanted the same ratio as the other one, that's a similar thing, yes. Okay. What I was thinking is plans. Okay. Have you ever seen plans? Anybody ever seen plans for a house?
Mm-hmm.
Plans for building a cabinet?
Oh, blueprints.
Okay. Blueprints. Another one is called the blueprints. So when you build stuff, a lot of times they don't give you a 3D model of it. What they do is they give you the blueprints or the plans, and then you have to take that and make it into the object, okay? So plans are a 2-dimensional look at a building. I'm going to call it building. That could be, it's not just a building, it could be a bookcase you're building, it could be a end table that you're building. There are plans for it, okay? Usually with blueprints, with two-dimensional, you have to look at each side, okay? You have to look at each side individually, because I can't put them all together on one dimension or on two dimensions. So you look at each side and you get what it looks like, and then you can look at also the top and bottom if you need to. Most of the time in buildings, these are just kind of fit in there, okay? They tell you what the size of the top and bottom is, and that's all, okay? So let's say we have something like this. Okay, this is a wall. I went and measured my wall. My wall was 8 by 32, okay, feet, 8 feet by 32 feet. Okay. But I don't want to draw it 8 feet by 32 feet, because you know how big that would be? The same size as your wall, okay? You don't want that. That would not be how the plans are drawn, okay? Does anybody know what scale they use a lot of times for plans?
1/100.
Some of them can use 1/100th of scale, that's a scale.
64, no.
Those are scales of models, and we'll talk more about that. They are some scales of models, okay? Usually, it's a 1/4 inch equals 1 foot, okay? A 1/4 inch equals 1 foot, but it could be 1 centimeter equals 1 foot. It could be, it could be whatever you want. You can make it 3 centimeters equals 1 foot. You can make it a 1/2 inch is equal to 1 foot. Just depending on what size you want to make the scale drawing.
So you could do like 2 feet is 1 foot.
2 feet is 1 foot, that
Make it
would
really big.
enlarge it.
Make a really big one.
That would not be making it a plan that you can read on paper. Because if I take this wall and I make it twice as big, that is not a plan we're gonna look at on paper, okay? So you take the wall, so let's do it 1/4 to 1 foot. So if you're looking at this, I'm gonna go ahead and move it over here. Our ratio, or our ratio rate, our rate is 1/4 inch is the same as 1 foot. Okay, right? That's our that's the ratio. I'm choosing this one. Okay. So I want to know how long I should make this on my paper. Okay. Well, if I'm going to make it on my paper, I know this is 8 feet tall. So I know the feet, and what I want to know is how many inches I'm going to have. Do you see that that's a proportion I can use? Okay. Here's my rate. 1/4 inch is the same as 1 foot. Okay. I know that my picture is 8, or my wall is 8 feet. So on my paper, how big am I going to make it?
2 inches.
Okay, well, we're just going to do that. So 1/4 times 1/8. We're going to take 1/4 times 8, because we're multiplying these across. And then we're going to divide it by 1. Well, what is 1/4? So what we get is 1/4 times 8/1, which is 8/4, which reduces down to 2. So we are going to make this one on our paper 2 inches. Okay, so when I make it 2 inches, that will give me the 1/4 to 8 or to a foot. Okay, so in real life it's 8 feet. On our paper, we're going to make it 2 inches so we can see it. Okay? But we're going to have to use the same ratio for the 32. So now we want 1/4, and I'm gonna use 0.25 because that works out as 1/4 exactly over 1 equals 32 and x. This will give me how many inches it will be on paper. Okay, so we take 0.25 times 32 and we're going to divide it by 1. So we get 0.25 times 32, which is really just dividing that by 4. Okay, so it's going to equal 8. You can double check that. So this is going to be 8 inches, which in real life, let's put it inside, it's 32 feet. Okay, so we don't necessarily put these measurements on there, but you can measure them on the plan, and you know that 2 inches really means 8 feet in real life. Okay, then most walls are not blank. Like, look at this wall. It has windows in it. This wall has windows in it. That wall has a door and a cupboard. This wall here has 2 doors. We also have some things we've put up on the walls or next to the walls that we could put in there also. But let's say we measure that. I happen to know those windows are 4 feet by 4 feet. Okay? They are 4, I'm just telling you, I measured them. That's the inside. The inside of the windows are 4 feet by 4 feet. Okay?
If you look
So-
at an angle, it looks rectangular. If you look
Yeah, it does, but they aren't. Believe me, I thought they were, they aren't, because I measured them. Because I was trying to get that board cut, so I had to measure them, and they're 4 feet by 4 feet, okay? So then you can measure where they're placed, so you can figure out how far from the end of the wall, how far up. Then you could draw the 4 foot by 4 foot in there by using those measurements. I would have to find out how far are they from the end of one wall. Then I'd measure up from the floor. So we'd have to get this and change it into inches. Change this into inches. And 4 feet, we didn't figure 4 feet. 4 feet is actually going to be 1 inch. So this would be drawn as 1 inch by 1 inch. I don't know the dimensions there, but because it's 4 feet each, 1/4 of an inch makes a foot. So 4 times 1/4 is really just 1, and so it's 1 inch big. Okay, so we can draw 2-dimensional plans. In fact, tomorrow, as part of your project, and I don't know if you're going to be in this room or not, but each of you are going to be put into a group, and you're going to start doing measurements and making the plan for one wall. You don't have to do all the walls. Okay? So that's one way we use scale figures. Okay? There are plans for making all sorts of things. Everything that's manufactured usually has a 2-dimensional plan to it. So if you go into where they're making cars, in fact, an architect, he draws up all of these plans to make a house. An engineer makes up the plans that go along with how you build a car, a bomb, I'm just thinking of things they build, a car, a bomb, a bus, an airline, an airplane, a tractor, a water faucet. I mean, there's all sorts of things, and they draw up those plans. They put them on 2 dimensions, like this. That's how you get your plans. You don't usually get scale models, okay? But a lot of times they do models. So 2-dimensional is when you can put it on a single sheet of paper and look at it. Those are usually called plans or blueprints, whichever one you want to call it. That's 2-dimensional. 3-dimensional. 3-dimensional similar figures. are usually models. Okay, that represent the same thing. Somebody was talking about there's 64 scale. I'm not sure if that's trains or cars, and it might be everything. 64 scale basically means that 1 inch is equal to 64 feet. Okay, so if you have models come in different scales, okay, whatever scale it is, usually that is what 1 inch represents, how many feet it represents. Or it's 1/64th of the original model. Okay, so you come up with this, so if they say that's actually true, it is. So if it's 64 scale, it's 1/64th of the original, the ratio is 1/64. Okay, so you take whatever the size of it is in real life, and you figure out what the size of it's going to be. And that's for every single part of that model. Everything is measured, so it's exactly to scale, and everything is calculated how big it will be based on that ratio. Okay. Sometimes, so models, I'm not sure they call them prototypes. So when people are making something, a lot of times they'll make something smaller, so they've designed some sort of plan, okay? They will make it smaller just to see how it looks. So they're making, so here's where your printer, your 3D printer comes into play. They didn't used to be able to do it with 3D printers, but now they can do it with 3D printers. They program it in, it prints out a prototype, which is basically what it looks like, but just made really small, okay? And they start looking at that prototype. People do this with buildings. They will look at the building, they'll have a 3D building that just fits on a table, okay? And they will look at it to make sure it's looking pleasing to the eye, the things that they've done look good. So they've made what's called a prototype of it. They've made a model of it. Model to me is the best word, but another word they use is called a prototype. Okay. Again, if you measure something, so let's just say, I don't know why I'm using this one, but because one of my students did this, they took and they made a model of a, what is that called? A brace-
Microwave?
No, this is actually has tracks on it, they shoot guns, a tank, okay? He made a model of a tank. It was really good, actually, okay? So what he did is he looked down from the top to get the measurements, right? Okay, so he actually found the measurements of this tank online, okay? So then he also had the other, so this would be the two-dimensional top, and then he had the side one, which looked kind of like this. And then it had a track in here. I'm just kind of making that. So from this side, and then the gun went out, okay? So this would be a side view, the 2D side view. So he's looking at them from both views. He's got the proportions, so he knows how tall this is based on what the scale is. So say it's 1/64th scale, okay? I don't know how big a tank is. I should know these things, but you know. So
The barrel can lift up and it's side to side and swivel and go up.
yeah, this one didn't, okay? He did have chain though that was actually put on this, and it could go around when you pushed it, okay, when he built it, okay? You would also have a front view. What does it look like from the front? Okay, from the front, you're just gonna have this part with a little bit of the chain showing, which is hard to indicate. And then you would have something coming straight out at you, and he put 2 headlights in it. Don't ask me why, he just did that, okay? So that's the front view. And then again, you want to know the dimensions of each part that's there so you can do it to scale. Okay, so you would measure it in real life, and then if you're doing 1 to 64, so let's say it is 32 feet long. Our scale's going to be 1 to 64. Okay, what we would do then is figure out how big we're going to make it. We could do this as 1 inch to 64 feet. Okay. So I want to know how many inches it's going to be long, because what we found out was in real life, this is 32 feet long. I want to know how big to make it in my model. Okay, so I would take this 1 times 32, because you're multiplying. 1 times 32 will equal, divided by 64 will equal the number of inches I'm looking for. Well, 32 divided by 64 is 1/2. It reduces down to 1/2. So 1/2 inch is how big I'm going to make. 1/2 inch, that's really solid. Let's go 1 foot to 1 foot here. There we go. We're gonna make it 1/2 foot. So I could make this as 1/2 of a foot, or 6 inches, and that would be how big I would make the model of it. Okay, so you have to have all the dimensions to make your 3D model. You have to have every dimension from every angle to make sure that they're all the same, they're all correct. Does that kind of make sense? Okay. You're gonna ask to part of your homework this week will be is you're gonna be asked to make a 3D model of your room at home, okay? And you're going to put in even some of the stuff, the decorations and stuff, but you have to figure out, measure it, make the 2D stuff, figure out then, how do I make it out of cardboard or something like that? We're not looking for fancy stuff, okay? And then you're going to bring that in as a scale model, okay? If you have a lot of junk in your room, you don't have to put all the junk in your room, okay? I'm not asking for that. Put like the bed and some bed stands or something like that in there, but you don't have to do that. We are not doing the roof. We're gonna exclude the roof so that we can see into your bedroom.
What about the walls?
You are doing the walls, yes.
Is it gonna be next week?
It's gonna be due next Tuesday, next Tuesday. You're gonna start it tomorrow. She's gonna talk to you more about it tomorrow, okay? But that is gonna be a project,
So tomorrow's project here will get us ready for project, right?
kind of, yeah. She will help you go through that a little bit, but it's basically the same thing. You're gonna make measurements of your room. You're gonna scale it down to a size that you can either cut cardboard out of or whatever, so that you can do that. Then you're gonna place your windows. You do not have to cut the windows out. You could draw them, but you need to draw them exactly where they should be in your room. If you wanna draw them, put curtains on them, put a blue sky outside, I don't care. You can be as elaborate as possible on it. But then I am gonna ask you to put the major furniture in there. So like a bed, a nightstand, those kind of things, a chair. So I want them scaled and put in where they're at in the book, or in the thing. So you make those, yeah.
What about like a closet?
If you have a closet, you can extend it out, or you can just put the doors that go to the closet and show the doors on the wall. Okay, so I'm not asking you to actually put the closet in there and add it to there. You can just show where the closet doors are and put those in to scale by drawing them or by putting them in. It depends on what you want to do. Last year I had people that got very elaborate on this project and did very detailed work.
You get more points the more detail.
No, but it's just fun.
Are we allowed to use a 3D printer?
Are you allowed to? No. The reason why, unless you can prove to me that you input all of that in there for your house, because you'd have to put it in and make it work. Do you know how to do that?
Yeah.
You do?
Yeah, I could make the 3.
Okay, for what? For the walls and everything?
For everything.
Okay, if you want to do that, but you need to show me the program that you did. Okay, and I'm gonna look at it and then I may ask somebody if that's actually what your bedroom looks like. I do know what your brother, I have contact with your brother, so I can ask him if that's what it is. So if you know how to do it, actually putting stuff in, because it's gonna be yours, so, you know, putting it in, but I want to see your room as a scale model. That does take some talent. You are doing ratios to make that scale work. I'll print it.
Do you want us to measure our room and then exactly scale it down to your?
Yes, I do.
How
I
much do you
want-
want us to scale it down by?
You get to use your own scale to make it. You can determine the scale.
So if we make like 90.
Well, I want to be able to see and distinguish some stuff, so don't make it so tiny I can't see and distinguish what it is.
What if we bring a microscope?
No. Okay, let's not push the envelopes here, guys. You know what I'm asking for, so just be,
Actually meant that though, I have a microscope.
yeah, no, I don't want it that small. Okay, so let's do a couple example problems like what you're gonna do in the book. Actually, let's take a break first, we'll come back and we'll do some example problems.